A particle moves along the x-axis so that its acceleration at any time t is given by the equation a of t equals 6t minus 18. At time t equals 0, the velocity of the particle is v of 0 equals 24, and at time t equals 1, its position is x of 1 equals 20. Part A reads, write an expression for the velocity v of t of the particle at any time t. And remember, in the original problem, the only equation we were given was a of t equals 6t minus 18. So something should kind of go off in your head that says, hey, to get to velocity from acceleration, I need to integrate. So we have the relationship v of t equals the integral of a of t dt. So we're going to plug in our equation for a of t into that equation, and when you integrate, you get 3t squared minus 18t plus c. Do not forget your constant because you do not have limits of integration. So we're going to find the constant by using our given v of 0 equals 24. So we will set 24 equal to the 3t squared minus 18t and plug in 0 for t. And when you do that, you get c equals 24. So your final velocity expression is v of t equals 3t squared minus 18t plus 24. Part B of the problem reads, for what values of t is the particle at rest? And when you hear at rest, you should immediately think velocity equal to 0, because any other velocity that is not 0 means you are moving to some extent. So we have the velocity equation from part A, v of t equals 3t squared minus 18t plus 24, and we're going to set that equal to 0 because we are wanting to find when the particle is at rest. So once you factor that and solve it out, you get that the particle is at rest at times t equals 4 and t equals 2. Part C reads, write an expression for the position x of t of the particle at any time t. Now up to this point, the only equations we have are for velocity and acceleration with respect to time, and that means we need to integrate velocity because velocity is the derivative of position. So we're going to integrate our velocity equation, 3t squared minus 18t plus 24, with respect to time, and that comes out to t cubed minus 9t squared plus 24t plus c. And again, do not forget your c, otherwise that can mess up your problem. So now we're going to solve for c using that original x of 1 equals 20 given in the original problem. So we're going to set 20 equal to our position equation, and we plug in 1 for all the t's, and we get that c equals 4. So the final answer for part C is x of t equals t cubed minus 9t squared plus 24t plus 4. Part D reads, find the total distance traveled by the particle from t equals 1 to t equals 3. So for total distance, you can use this lovely model that I know everyone appreciates in calculus to track the position and calculate how far it's going each time. So in the original problem, we're given x of 1 equals 20, so let's start there. And then when you plug in 2 to this equation up here, you get 24. So we know that we have moved right 4 units, which is what this right here shows. Okay, so then let's plug in the next time t equals 3, because we're going from t equals 1 to t equals 3. So when we plug in 3 to this equation up here from part C, we get 22. And we know that from 24 to 22, we're traveling 2 units. So 4 plus 2 equals 6. So our total distance is 6.